Hello students, welcome back. I hope you're all fine, very good, healthy, wealthy and well. Okay students, so we are going to summarize our chapter Euclid's geometry in this complete lecture. Okay, so we are going to revise it very quickly. Okay, so in that chain we are going to start with the first point, that what we have studied. In this chapter we have studied the following point. The first is Euclid defined a point, a line and a plane. The definitions are not accepted by a mathematician. Okay, therefore these terms are now taken as undefined. So these particular definitions, point, line and plane, are not defined, okay, are assumed to be not defined by the mathematicians of today's time. Okay, so these are the undefined terms. You just need to understand them with some examples, okay, in some manner. Axioms or postulate, these two things are the assumptions which are obvious universal truths. They are not proved. They need not to prove, because you can just know that they are true by the you can say that by the observations, by the day-to-day activity you are having. So by these things only, by so obvious things you are having, these axioms and postulates to be true, so they need not to be proven. Now theorems and statements which are proved using definitions, axioms, previously proved statement and deductive reasoning. Theorems, what are theorems? Theorems are statement. Now we have studied a lot of theorems. What we did, the theorem have been proven with the help of some other theorem or some statement or a previous theory that was all about it. So we used something to prove something, and that something is now the theorem. So these theorems are what is the first thing that need to be proven? Okay, at some point you are going to have something that is not need to be proven. You are going to assume that yes, it is something like it is. So theorems are statements which are proven using definitions, axioms, previously proven statements and deductive reasoning, right? So these are the things by which you prove the theorem part, right? Okay, next, in the next point we had the Euclid's axiom. Now the Euclid's axiom, I have told you, these are of very great importance. The first one was, things which are equal to the same thing are equal to one another. I have told you that if 1 is equals to 1, okay, then and 2 minus 1 is equals to 1, then 1 is equals to simply 2 minus 1. This one is also equals to this 2 minus 1. Okay, and I can say that if A is equals to B and B is equals to C, then A is also equals to C, right? The second thing, equals are added to equals, the wholes are equal, right? Like if A plus B is equals to C, okay, so if equals are added to equal, now A is equals to what? D, and let's suppose B equals to E. Now if you add B and E, that is going to also be C. Okay, when equals are added, they are going to be equal, right? Okay. The third thing is, if equals subtracted from equals, the remainders are equal. Okay, now if I am going to these are two equals, and we subtracted B here and C here, so B is equals to C. If B is equals to C, in this case, if this is D, this is going to also be D. That means if equals are subtracted from equals, the remainders are equal. If equals are subtracted from equals, then the remainders are also equals. Okay. Now, next was, things which coincide with one another are equal to one another. Things which coincide, I have told you, if this is one palm of mine and I'm overlapping it with the second, okay, so if it's coinciding, each and every part of this first hand is coinciding the second part. If it's doing so, that means what? You cannot see the next this hand from this side, and that goes from this side too. Okay, so I can just turn here like that. Okay, so you cannot see this hand from there. So that means they are coinciding. If they are coinciding, that means, what does that mean? If they one another are equal, things which are coincide, which are one equal to one another. That means this hand is equal to this hand. Okay, now the fifth one is the whole is greater than the part. The whole is greater than the part. And this is a very important thing. I have told you the fifth axiom here, right? The fifth axiom here. Fifth postulate is also very important. Fifth axiom is whole is greater than the part. I have told you about the pizza. Okay, here this part always will be shorter than this complete pizza. That means the whole is always the greater from the part. Okay, now next, the things which are double of some things are equal to one another. If A is equals to B, now if we are having 2A and which is equals to C, then 2B will also be equals to C. So if we are doubling same things, they are going to be same. So things which are double of the same thing are equal to one another. And we have taken some good example of it, like a water bottle or something, and we use that water, something like that. So in that particular part we understood it very well. Okay, so here the next one is things which are half of some things, same things, are equal to one another. Now if again A is equals to B, right, and we are having A by 2 also equals to B by 2, right. Now things which are halves of same thing are equal to one another. These two, A by 2 and B by 2, will also be equal. Let's suppose A is equals to 8, right. In that way, if A is equals to 8, then B is also equals to 8, because A is equals to B. Now if I am going to write A equals to B, A by 2, then that is going to 4. If I am going to write B by 2, that is going to be 4. That means 4 is equals to 4. That means A by 2 is equals to B by 2, because A is equals to B. Okay, that means things which are half of same things are equal to one another. They are very, very, very small things. Okay, we don't need to be panic so much for that. Right, the fifth one is Euclid's postulate. The fifth point, Euclid's postulate. We have gone through the postulates of Euclid. The first one was a straight line may be drawn from any point to any other point. A straight line may be drawn from any point to any other point. If this is the point, this is the second point, straight line can be drawn between these 2 points. A straight line. A terminated line can be produced indefinitely. If I am having a terminated line, the terminated line I have told you is nothing, a line segment is nothing but a line segment. So I can produce it in this direction, indefinitely, right? It can goes on and on and on and on. Okay, it will never stop. Now the third one is a circle can be drawn with any center and with any radius. So if this is center, I can have a center here. If this is the center, that can be a circle, that can be a circle, that can be a circle. Okay, and if this is the center, this is the circle, this is the circle, this can be a circle, and similarly goes for each and every point. So from each and every point, and then in whatever radius you want it to, you can draw as many circles as you want to, right. Then the fourth one goes, all right angles are equal to another. Right angles are what? 90-degree angle, perpendiculars. So if this is 90 degree and this is 90 degree, this 90 degree is going to be equal to this 90 degree. All right angles are equal to one another. Postulate number 5 was, that is going to be important. Postulate number 5 was very important, that if a straight line falling on 2 straight lines make the interior angles on the same side of it taken together less than 2 right angles, then the 2 straight lines, if a product produced indefinitely, meet on that side on which the sum of angles is less than 2 right angles. What does that mean? If I am having two lines, that is not going to be parallel, okay, and I am having two lines. So if I'll be measuring these angles A, B, C, D. Here, if I'm talking about these 2 angles and these 2 angles, so A plus B A plus D is going to be have some numbers, and B plus C is going to have some numbers in degrees. Okay, so if I'm adding these two, A and D, and this is going to be what? This is going to be less than 180 degree, and this is going to be more than 180 degree. Then, and that side, where it is more than 180 degree, or you can say more than 2 right angles. Right, at this point, these two lines are never going to meet each other. So where it is going to meet each other? Where the sum is less than 180 degree. If here the sum is less than 180 degree, then this is going to meet. Now what if the sum is 180 degree or sum is equals to 90 degree, two right angles, then also never going to meet on that side, right? The thing is, if I am having these two lines, and this is L, this is M, this is N, and this is L, and I am having these four angles, say A, B, C, D. Now, if A plus C is equals to, let's suppose, 2 right angles, that is equals to 180 degree. In that condition also it is not going to meet. If these two angles are going to be 180 degree, these two angles are also B plus D is also going to be 180 degree. In this condition, these two lines M and N are parallel to each other. They are not going to meet this side, they are not going to meet each other on that side. So these can be the conversions of the postulate number 5. So is that clear to you for now? Now the sixth one, two equidistant versions of Euclid's fifth postulates are, okay, so first play fairs, for every line L and for every point M not lying on L, there exists a unique line M passing through point P and parallel to L. So we are having a line here. Other than this line, we are having a point which is not in the line, okay, P. Then for this line L, we can always draw a line M which is parallel to L and passing through P, right? Okay. Now, the second one, or the second part of it is, second conversion of it is, two distinct intersecting lines cannot be parallel to the same line. If two lines are intersecting, M and N, and if we are having a line which is parallel to N or M, let's suppose N is parallel to L, then L can never be parallel to M. These two lines N and M can never be parallel to the same line, right? Okay. Now, next, all the attempts to prove Euclid's fifth postulate using the first four postulates failed, but they led to the discovery of several other geometries called non-Euclidean geometry. Okay, so when these scientists and researchers have that these points, and they never proved this fifth one, but they also discovered many of the things that we are currently studying. And when you read this complete chapter, understood this complete chapter, you have understood also that all the things basically, maybe some nomenclature may be different, okay, or maybe the words may be different. The theorem is not as it is as you have seen it earlier in your chapters in your modern geometry, but things are very much similar to the previous one that you are actually studying right now. So that led to discovery of several other geometries, that is non-Euclidean geometry. So this is about the complete summary of your chapter. Now you have to revise it thoroughly and do some good questions on it. We have completed all the important questions these classes. Okay, so now you can just have some good more questions of this, and if you are done with all these lectures, you basically completely covered all the important part of this chapter. Okay students, so take good care of yourself and study hard. Bye bye.